Hello everyone, I'm Shrabani Tripathy. I have done my PhD in IDP in Climate Studies in 2022 with a thesis titled Real-Time Flood Risk Forecasting and Evacuation. And today I'm going to talk briefly about the work done in the thesis. Whenever we open a newspaper or a news channel or any social media website nowadays, we come across such articles which questions the predicting ability of extremes and the losses we are suffering from every day in different parts of the world. And these articles brings questions to our minds such as, are we not able to predict extreme events correctly? Why there exists a gap between the prediction and preparedness? And can these losses be minimized? To answer these questions, first we need to understand how the traditional flood forecasting method works. The traditional flood forecasting uses output from weather models in hydrologic and hydraulic model to generate inundation values, and based on the flood inundation values, flood warnings are generated. However, the state-of-art weather forecast models are often associated with huge amount of biases and uncertainty, which makes the forecast unreliable. Uh, as it has a very low hit rate and high false alarms, and the forecast efficiency gets lower with high lead time. The major drawback of the traditional flood forecasting system is the flood warning generation for two separate regions, let's say for a urban area and for a barren land, only depends on the inundation value. However, the severity that the area suffers doesn't only depend on the amount of rainfall or the amount of flood. It also depends on regional characteristics like topography, land use, land cover, socioeconomic vulnerability, etc., which are not considered while generating these warnings. So, to overcome the drawback, we have proposed a model which uses flood risk in real time to generate warning. This flood risk is calculated as a combination of hazard, vulnerability, and exposure. Hazard takes care of the flood, the rainfall forecasting part. Hazard is defined as the probability of getting an extreme given any forecast value. In a copula-based model, using the model hindcast and observational data, we generate the bivariate distribution, which gives us the joint probability based which gives us a joint probability, and you based on any flood forecast, any rainfall forecast value f, we compute hazard. Similarly, vulnerability is computed as a combination of topographic and socioeconomic vulnerability. Topographic vulnerability is computed using a elevation data in a height above the nearest drainage model. The height above the nearest drainage model converts the elevation value from a mean sea level value to the value with respect to the nearest drainage. Similarly, census data, the demographic data in an indicator-based model is used to compute the socioeconomic vulnerability, and land use land cover data is used to compute the exposure. The concept of using flood risk in a real-time scenario to generate flood warning is a new concept, and this method is applied for a Indian patent. The application has been filed, and it is in the last step of the processes are going on. To validate the model, we need to apply it to a real life event. So we have applied it to the Kerala flood of August 2018, and the total losses that each district suffered from the post-disaster assessment report is used as an indicator of the severity of the flood. And flood risk maps, relative risk maps are generated at sub-district level for different lead days starting from lead day 15. And we see that starting from lead day 15, the model is able to identify most of the high risk areas, and thus this helps us identifying the risk hotspots, so that rather than focusing on a whole state or 2-3 states during any extreme events, we can only focus on the high risk areas to do any mitigation planning so that the losses can be minimized. Apart from Apart from flood identification and forecasting, mitigation planning is also very important in minimizing the losses, and the evacuation planning is one of the key steps in a mitigation planning. The only objective during evacuation planning is to evacuate maximum number of people from one village to one shelter. Shelters are safe places where people get evacuated during flood, and they stay there for a certain amount of days when there is a flood. However, in the current COVID-19 like scenario, another objective comes into a picture of evacuation planning, which is to keep the COVID-19 infection under control. So if we overdo the evacuation, the flood risk may be minimized, but the chances of an outbreak of COVID-19 is very high post the flood. Similarly, if we underdo the evacuation, the chances of people getting affected by the flood is very high. So these two objectives are conflicting in nature. That's why we have proposed a multi-objective optimization model, which uses two objectives. First one is to maximize the reduction in flood hazard in each village, and the second one is to minimize the number of infection in each shelter after the flood. So during the flood duration, optimum number of people should be evacuated from one village to one shelter. This problem is solved using a maximum approach in PGSL, and the number of infection is calculated using a Sears plus model, which is an epidemiology model, which calculates the number of infection based on the total number of population in one shelter and the initial infection in the shelter. So the optimization model is able to reduce the number of infection by considering a new objective. Also, this model is able to evacuate less number of people from villages which suffer a higher initial infection rate. The major contributions from the thesis are we we have proposed a new model which uses regional characteristics along with the forecasted rainfall to generate real-time flood risk warning. The concept of using real-time flood risk warning is a new concept, and that a patent is filed for this approach. The hazard value, when combined with vulnerability and exposure, gives a relative risk, which enables us to identify high-risk areas and hotspot areas in a larger region, so that the evacuation planning or any regional regional hydrologic modeling can be done for those areas only rather than focusing on a larger area. Apart from flood risk forecasting, the multiple solution that we get from the multi-objective optimization model, which takes care of the evacuation planning, gives us multiple solution, which is very useful for stakeholders as they can use any of these solutions for real-time problems. And also the multi-objective optimization problem is a generic approach which can be applied to evacuation planning for any extreme events like cyclones, earthquakes, etc., and to any other infections like cholera and other diseases that can happen post any extreme. So these are the outcomes in terms of publications. There are three research articles which are published and one patent which has been filed. Thank you so much.